Hi guys, so today's presentation will be on the different types of sequences. Okay, so there are four types that you need to know about. Now the first type is linear sequences. Now these are the most easy ones that you probably see in school. Now there are sequences where the difference between each term is the same. Okay, so another way of describing them is that the terms add or subtract the same number each time. So, for example, if I had 3, 5, 7, 9, as you can see, each time I'm plussing 2. So to get from 3 to 5, I'm adding 2. From 5 to 7, I add 2 again. And from 7 to 9, I add 2 again. So for this sequence, the rule is add 2. And if I want to find the next term, all I do is plus 2. And that will give me 11. Okay. So let me show you another example. So you could have 11, 15, 19, 23. So as you can see in this sequence, I want to see how do I get from 11 to 15. So if you're not sure, just do 15, take away 11. That will give you positive 4. Okay. How did I get from 15 to 19? Add 4 again. 19 to 23, add 4 again. Okay, so if I want to find out the next term, I just add 4. 23 plus 4 gives me 27. So the rule here is add 4. Okay, so these are some examples of some linear sequences. Basically, you're adding and subtracting by the same number each time to get the next term. Okay, now another sequence that you need to know about is called a geometric let's do quadratic sequences first. So quadratic sequences. Okay, now in quadratic sequences, the difference between each term is different. Okay, so for example, uh, if I have a sequence like 5, 7, 11, 17, here you can see the difference between each term is not the same. Okay, so how do I get from 5 to 7? Let's have a look. I plus 2. So from 5 to 7, I plus 2. 7 to 11 plus 4. 11 to 17 plus 6. But what you're going to notice about quadratic sequences is the difference of the difference. So from 2 to 4, from 4 to 6 is going to be always the same. So in maths, guys, we call this the first difference. Okay, these numbers here are the first differences. Then this number here, the second difference, which in a quadratic has to be the same number, is called the second difference. Okay, so in this question, the second difference is 2. Okay, so now if I want to find the next term of this sequence, I know I need to add, so I need to add something here to find out what it is. I plus 2 to 6, so plus 2 to 6 to get plus 8. So 17 plus 8 gives me 25. Okay, let's try another example. So let's say we have 2, 5, 12, 23. Okay, so here we have another quadratic sequence. So let's see what the first difference is. Plus 3, plus 7, 23 take away 12. That gives me 11. Okay, now the second difference, let's have a look. Now the second difference, as you can see, is plus 4. Okay, now it should be the same, otherwise you've made a mistake in your first difference. Now let me get the next term. So to the 11, I'm going to add 4. So 11 add 4 gives me 15. So 23 plus 15 gives me 38. Okay, so that will be my next term in my sequence. Now, the remaining two sequences that you need to know about so make sure, guys, you pause the video, take notes, make sure you understand this section, and then move on to the next section that I'm going to talk about. Okay, so the next sequence that you need to know about is geometric sequences. Now, these are similar to linear sequences, but instead of adding or subtracting between each term, you're multiplying by the same number. And this same number is called the common ratio. Okay, so for example, if I have 3, 9, 27, yeah. So in this sequence, as you can see, to get from 3 to 9, I have to multiply by 3. Okay, 9 to 27. So if I do 27 divided by 9, that will give me 3. So times 3 again, and so on. So in this sequence, the pattern is multiply by 3. Okay, so to get the next term, all I need to do, times by 3 again. 27 multiplied by 3. 7 times 3 is 21. Carry the 2. 2 times 3 is 6. 81. So that gives me 81. Okay. So the common ratio here in this sequence was 3. Okay. Let's try another example. So let's say I have 4, 8, 16. Now in this one, guys, as you can see, is multiplied by 2. Okay, if you're stuck, just do 16 divided by 8. That gives you 2. You can do 8 divided by 4. That gives you 2. So here, my common ratio is 2. And to get the next term, all I do, multiply 16 by 2 to get 32. Okay, so those are some examples of geometric sequences. Also, you could go down. So let's say I had 40, 20, 10. So in this sequence, guys, as you can see, the difference is divide by 2. Okay, so the common ratio is divide by 2, or a half. Yeah, so times by a half. Okay, so that would be the common ratio. To get the next term, 10 divided by 2 or times by a half gives me 5. Next term, 2.5. Next term, 1.25, and so on, guys. Okay, so that's geometric sequences. And the last type of sequences that you need to know about are special sequences. So one type of special sequence is called the Fibonacci sequence. Okay, now this was invented by a man called Fibonacci. Now, it starts off, you choose two numbers. So the original Fibonacci sequence starts off with 0 and 1. So let's choose 0 and 1, two consecutive numbers. Now to get the next term, all I do is add the two previous terms. So 1 plus 0. Yeah, so to get the next term, I have to do 1 plus 0, which is 1. Okay, to get the next term, I have to do 1 plus 1, which is 2. Next term, I have to do 2 plus 1, which is 3. Next term, I have to do 3 plus 2, which is 5. then 5 plus 3, which is 8, then 8 plus 5, 13, 13 plus 8, 21, and so on. So this sequence carries on forever, guys. It's an infinite sequence. Now let's try another one. So choose two consecutive numbers. Let's say 10 and 11. Carry out the Fibonacci sequence, the rule. So add the two previous terms. 10 plus 11 is 21. 21 plus 11 is 32. Then 32 plus 21, you get 53, and so on. Now you might think, why is this sequence special? But this sequence is special because it's noticed in nature everywhere you look. So everywhere you look, you will see this Fibonacci sequence. Now, guys, if you don't believe me, type in YouTube, guys, watch a video on it. So type in Fibonacci in real life, in nature, and you will see many examples where this sequence is seen in nature. Okay, guys, so I hope you enjoyed today's video. Make sure you